This problem gives us a prism in air and asked us to show that the index of refraction n is given by this expression when we vary theta so that the light enters and emerges symmetrically. Under this condition, alpha equals theta, the light will be horizontal inside, and if we extend these lines, they'll intersect in the middle. The angle between them here is the angle of deviation. It's the angle that the ray turns from coming in to going out. The prism's index is n, with the index of air being 1. We'll find this index using Snell's law. To do that, let's identify the incident and refracted angles. The incident angle is theta, and the refracted angle is theta 2, shown here, so that n air sine theta equals n sine theta 2. Solve this for the index of the prism, and it equals sine theta over sine theta 2. So apparently what we're asked to show is equivalent to showing that the angle theta is 1/2 psi plus phi, and the angle theta 2 is equal to 1/2 of phi. Let's find the angle theta 2 first and show that it equals half of phi. We'll do this by looking at this green triangle. If this angle is beta on both sides, then phi plus 2 beta equals 180 degrees. We also know that beta plus theta 2 forms a right angle. So if we solve this second equation for beta and substitute it into the first, we get this result. The 180 degrees cancel, and we see that theta 2 is half of phi. And that's what we needed to show, to have the denominator look like it's supposed to in the answer. Now let's erase this and work on the angle theta. I'll solve this part of the problem by writing down a whole bunch of different things that sum to 180 degrees. First, let's look at this triangle. There's two angle theta 2's, and there's this new angle, which I'll call, I don't know the name of this variable, let's call it squiggle. So 2 theta 2 plus squiggle is 180 degrees. Twice theta 2 is the angle phi. So there's another expression that equals 180. Let's make another triangle with this angle delta, so that phi plus delta equals 180. And now another set. Call this angle gamma, and notice that it equals theta minus theta 2. So we can write that 2 gamma plus delta equals 180. That means that phi equals 2 gamma, which is twice theta minus theta 2. Solve this for the angle theta. It's 1/2 of psi plus theta 2, which is 1/2 of the quantity phi plus psi, what we needed to show to make the numerator look like we were supposed to. So we've shown that when the ray enters and leaves at the same angle theta, that the index of refraction is sine of half psi plus phi divided by sine of half of phi.